Let's see if you and I can come in here and find the radius of convergence for this power series. Now, invariably, I'm going to be using the ratio test to determine the values of x for which this power series converges and diverges. And so taking a peek at the limit, as n increases without bound of the absolute value of the n plus first term to its predecessor, I will force that to be strictly less than 1, and I will solve for x. So, putting in the details. Maybe neglecting that last factor here, that really is the n plus first term in absolute values. Instead of dividing by the absolute value of a sub n, I'll multiply by its reciprocal. And since I did forget about this factor over here involving the variable x, keep in mind that if I divided the portion of the n plus first term divided by the nth term in absolute values, any of these in absolute values are going to cancel upstairs and downstairs. I'm merely left with 1. Now remember, I'm actually using the ratio test. The ratio test says I have convergence if this limit is strictly less than 1. So I'm going to solve this inequality for x. I'm going to find all values of x for which this inequality holds. And when I'm done, that'll allow me to identify what the radius is. May not know what the interval is because that would require me checking what's going on when this is equal to 1. For now, let's just solve this inequality. And keep in mind, as I'm walking along, it certainly is the case that since this factor in absolute values right here involves nothing with n, then it's basically outside the limit. As far as the garbage is concerned, looks like a mess, so I'm going to clean up. This factor. These three factors will not change. I will rewrite the second factor downstairs. And these two factors don't change. Now, as far as any cancellation is concerned, can we take care of these two? Maybe this one factor with one of these. And if you allow me to separate out, did I miss anything? Oh, looks like I missed this and this. And now, honestly, I'm a little nervous, so can we take a quick break and make sure I didn't skip anything? That's taken care of. So is that. Have these two done. Downstairs, got it. Good. There. Here, And lastly there, okay, I'm starting to like it. Now, as far as that first limit is concerned, something very special is going on, and you're going to see this repeated over and over again. Notice how in the numerator's position, you have a fifth degree polynomial whose leading coefficient is 9. Downstairs, you have a fifth degree polynomial function, also with the leading coefficient of positive 9. And so you'll see with these rational expressions, that limit will always go to 1. So I think the only thing left over is evaluating this limit. So allow me to give myself some room. So take a peek at this ratio right here. Isn't it the same thing as this? So I rewrote this ratio as, in parentheses, one single fraction inside of one set of parentheses. Now, technically speaking, I'm just stalling because I'm double checking my arithmetic. Technically speaking, the only thing I'm left with is a 3 on the outside. But of course, that's to give me this. Or this. Now, I don't know what you want to do at this point. We could say that if we divided both sides by 2, that would give me my radius. It works. But I'm kind of nervous with my first example. You might not see it. So how about this? Now remember, I only asked for the radius, not the interval of convergence. Bit of 9th grade high school algebra. So basically, the values of x for which I'm guaranteed I have convergence are from here to here, albeit I might converge for more values of x, namely at these endpoints individually, but I'm not going to check them. I only wanted the radius convergence. So if you don't see very easily at this stage of the game, the radius has to be this thing divided by 2. Then notice if you just take the left endpoint and subtract from the right endpoint, it's going to give you this. That'll be sort of like the length of the entire interval. So think of that on a number line as centered about, say, something like -1/2. You've got this interval like this. Now, if the full length of the interval is this, then I think the radius of convergence is simply half of that. Actually, did I misspeak? My goodness. The left endpoint subtract from the right endpoint. Isn't that really this? Because I got that minus that gives me 2 of them. That's the entire length. Half of which will be the radius of convergence. So I'm left with this. Kind of matches what I said before in reality. I can just take this as my radius of convergence, assuming the coefficient of x is 1. But since it's not divided in half, that gives you radius, but at least I just defined it with my algebra.